All right, today we're going to tackle what is, without a doubt, the most famous equation in all of science. It's an icon, right? A symbol of pure genius. And we're going to unlock what it really means. So, what is it? I bet it's already popped into your head. It's incredibly short, just 5 simple characters that basically unlocked a fundamental secret about the very fabric of our reality. And there it is, E equals mc squared. We've all seen it. It's on t-shirts, it's in movies, it's pretty much everywhere. But what does Albert Einstein's signature equation actually mean? Well, that's what we're going to get into right now. So let's dive right in and unpack the secret behind these 5 little characters. Because this is so much more than just a math problem, it's a profound, genuinely revolutionary idea about how the universe works. See, this isn't just some clever formula. What this equation reveals is a deep, fundamental truth. It tells us that mass and energy, which for centuries we thought were completely separate things, are, well, they're actually 2 sides of the very same coin. Okay, so to really get this, we've got to break it down piece by piece. Let's look at what each part of this powerful statement actually stands for, starting with the letters themselves. First up, you've got E, and E stands for energy. But we're not just talking about the energy of motion or heat. We're talking about the total energy of an object. This includes a pretty wild concept called rest energy. This is the huge amount of energy an object has just because it exists, just by being there. Okay, next we have M for mass. The easiest way to think about mass is just the amount of stuff an object is made of. It's the physical substance of the universe, whether we're talking about a tiny grain of sand or a massive star. And finally, we have C. Now, C stands for the speed of light in a vacuum. And this isn't just some random number. It is the ultimate speed limit of our universe. Nothing with mass can ever reach it. It's a true universal constant. Now, you have to understand what a huge shift this was. Before Einstein, science had 2 separate, almost sacred laws: the conservation of mass and the conservation of energy. They were completely different things. What Einstein did was come along and basically smash them together into one beautiful, unified idea. Mass is a form of energy, and energy has mass. But the true magic of this equation, the part that gives it its incredible, awesome power, isn't just the C. It's the C squared. And this is where things get really, really big. The speed of light is already a massive number, right? About 300 million meters per second. But when you square it, you get this, 90 quadrillion. That number is the conversion factor between mass and energy. It's just an astronomically huge multiplier. The funny thing is, the idea that matter was hiding some kind of incredible energy was actually floating around before Einstein. Way back in 1875, an engineer named S.T. Preston wrote about the immense power that was locked up inside a single grain of matter. But it was Einstein who finally gave the idea its exact mathematical form. So here's the bottom line. Because that C squared number is so ridiculously massive, it means that even a tiny, minuscule amount of mass can be converted into a truly staggering amount of energy. That is the core secret of this famous equation. So let's see how this actually plays out in the real world. Because this isn't just some abstract theory on a blackboard. It's the engine behind some of the most powerful forces we know, from the life-giving processes in stars to the most destructive weapons humans have ever made. This principle of mass-energy equivalence is at work literally all around us, all the time. It powers nuclear reactors through fission, it explains radioactive decay, and it's the very reason our sun shines, through the process of nuclear fusion. It's at the heart of the most fundamental interactions in the universe. Just think about the sun for a second. Every single second, it fuses about 600 million tons of hydrogen into helium. But if you look closely, the end product is actually a little bit lighter. About 4.5 million tons of mass simply vanish. So where does it go? It's converted directly into the enormous energy we see and feel as sunlight and heat, which, makes all life on Earth possible. And we see the exact same thing happening with radioactive decay. When a heavy element like uranium breaks down, the pieces that are left over have slightly less mass than the original atom. That missing mass, they call it the mass defect, is the source of the energy that gets released. Mass literally disappears and reappears as pure energy. Now, to be fair, Einstein didn't just conjure this idea out of thin air. There were other brilliant minds who were getting really, really close.
But his breakthrough was connecting it to something much, much bigger.
See, before 1905, other physicists had noticed these strange little connections between energy and mass, but only in very specific cases, like with electromagnetism. They were all seeing little pieces of the puzzle, but nobody was seeing the big picture. And this is what made Einstein's contribution so huge. His stroke of genius was realizing this wasn't just some quirk of light or radiation. He declared that it was a universal law. It applied to all mass and all energy everywhere in the universe, no exceptions. He made it a cornerstone of modern physics. And that just leaves us with a pretty mind-bending thought, doesn't it? This simple, 5-character equation revealed that the very stuff of our world is really just a condensed, frozen form of incredible energy. It really makes you wonder, what other profound secrets are hiding out there in plain sight, just waiting for the next equation to unlock them?